Hi, everyone. We're just going to wait a few minutes before we start while we admit other people. All right, good afternoon, everyone, and welcome to the first STE Colloquium of the year. We're very happy to see you all as Dr. Rob Schoen starts us out with the first colloquium of the year. The title of his research talk is Open Science: What, Why, and How. And just a little bit of a bio of Dr. Rob Schoen So he's an associate professor of mathematics education in the School of Teacher Ed and the associate director of the Florida Center for Research in Science, Technology, Engineering, and Mathematics at Florida State University. He received the Kenneth Kidd Mathematics Educator of the Year Award in 2022 from the Florida Council of Teachers of Math. Dr. Schoen has served as the principal investigator of more than 12 randomized controlled trials of promising interventions in mathematics and statistics education. In addition, he has developed and field tested a wide array of educational and psychological assessments designed to measure teacher knowledge and beliefs, instructional practice, student competence, and attitudes in mathematics and mathematics anxiety experienced by teachers and students. So just to go over the format of the talk, Dr. Schoen is going to present for about 25 to 30 minutes, and he has built in time in the presentation for questions, but we encourage you to ask any questions, to leave your questions also in the chat. And with that, we will have Dr. Rob Schoen start his talk.
Thank you. And it's great to see you all. I really appreciate that you took time on this Friday afternoon, especially this time of year when the heat maybe is starting to break. I know you have lots of other things to do, and in my best Delta flight attendant impersonation, I thank you for choosing to fly with us today. I'm going to take over the screen here, I think. So fair warning on that. All right, so far so good. Are you seeing my notes page or my?
Just the slides, slides, Rob.
Okay, great. And I left on, my PowerPoint has probably the best closed captioning system that I know of, so I left it on there. If that's bothersome, just let me know, but it's probably bothersome to me because I want to edit it and correct when it's my weird accent wrong. But the title of my talk is Open Science: What, Why, and How. That should probably be why, what, and how, but it felt a little more right to say it what, why, and how. That's what I'm going to talk about. So my colleagues and I have been working on this in bits and pieces and taking sort of incremental steps forward, trying to get on board with this movement for some time now. And I'll talk a little bit about that and kind of why I think it's important to do and what we've been doing and how you could get involved. So I want to start first with just a question, and I want to encourage everybody, feel free to use the chat feature throughout the talk. If you have comments or questions or so on, if you have experience or thoughts on open science, feel free to use the chat. But I want to ask you all this, and this is a question you can even put your answer in the chat if you want to guess. So what's the average number of times an author or group of authors submits a manuscript to a journal for consideration for publication before it's accepted in a refereed journal? And I think about this not just within the same journal, but how many times do you think it also gets rejected and then resubmitted to a new journal, and then rejected from that one, resubmitted to a new journal? Anybody have a guess? Yeah, like 2 to 3, 5 to 10, 5 or 6, 4. Yeah, 42. Yeah, Guillermo, you might be, come on down. You're the next contestant. So 20. I don't know what the number is actually. I don't know what an estimate of that number it is, but I'm sure it's probably more than 2 or 3, and it certainly is in my experience. So there's related to sort of publishing and refereed journals. Here is a diagram that I took from the Center for Open Science website that kind of talks about the things in red are sort of problems in our current system of peer review and publication and so on, and problems that really sort of threaten the very enterprise of science as far as science being able to help us find things that are true or correct, interventions, medications that work or don't work, and so forth. So some of the one of these is just lack of replication. So studies are often just one and done. We accept the results there and move on and assume they're true. There's some very disturbing research done, particularly in the medical field, that says that a lot of studies that are sort of replicated very often have lower effect sizes, at best than the original study did, and even more often don't have the same kind of result at all as the original. So I encourage you to learn about that if you've watched all the horror movies that you know of and you want to get really disturbed and scared by something else. Read some of the work, the scary research that's done on replication and how often things that are published and show low p-values and positive effects do not get sort of reproduced when another study is done, or even sometimes when somebody gets a hold of the same data and tries to reproduce it from even the same data. So that's a problem. Other problems are low statistical power or flaws in the design in general. A major problem is p-hacking, and I hope you're hip to that already. This idea that sort of researchers have degrees of freedom. I really like this phrase, researcher degrees of freedom. It's happening throughout, from start to finish, and all points in between. Researchers are making decisions. And I think we like to think that we're making unbiased decisions, but human beings are terrible at being aware of their own biases. And p-hacking is one thing that happens where people will dig around in their data and they know either explicitly or implicitly, they know that peer reviewers and editors are going to be more likely to want to publish their result if there's something with a low p-value, right? So they can make all kinds of subtle decisions that they may or may not even be aware of in order to sort of find some low p-value study, even better yet, one that aligns with our preconceived ideas and theories and so on of how things should be. So that's a real threat to validity and the whole enterprise of science. And publication bias is one that's kind of driving a lot of this. In fact, this is sort of the known phenomenon that peer reviewers and journal editors are more likely to recommend a paper to be published in a journal if the results, have, say, low p-values, or the findings are consistent with what we already believe to be true, and particularly that don't sort of run counter or against the grain to that. So there have been studies also in that area that show that studies that are published in peer-reviewed journals are much more likely to have those positive effects, and studies that are published outside of peer-reviewed journals are much less likely than those published in peer-reviewed journals to actually find results that are consistent with our preconceived ideas. And also related to this is this idea of harking, this sort of hypothesizing after results are known. So if you've ever sort of played pool, played pool or played horse, right? Like with friends, even playing basketball or something, there's this idea of sort of calling your shot, right? And if you sort of accidentally get the ball into the pocket or something, under the more rigorous rules of playing billiards, say that doesn't count, right? But a more rigorous way. So we kind of know this idea that calling your shot is more rigorous and requires a higher level of something than just sort of accidentally stumbling on something. So these are all major threats, in my view, to the integrity of the whole scientific enterprise. And publication bias in particular, I believe, drives a lot of this. So if you're not familiar with this blog, I recommend that you get familiar with it. Especially, if you need a little bit of therapy from dealing with reviewers who make, disrespectful, unhelpful comments. And once you're on your 19th and 20th time of submitting a paper, sometimes you need a little free therapy. I can't say the name of the blog out loud because my parents did not allow me to use such fancy language, but I'll put it there. These are some excerpts from the blog of things reviewers said, right? So here's one. If participants were recruited from a university, I imagine they'd usually be 18 to 22 years old. Why does your sample range from 18 to 63? I'm a bit lost, right? So I like the hashtag only teens in college. So this is just one of those many things that, I don't know, unthoughtful, uninformed reviewers might say. Here's another example of one. The fact that the question of this paper has never been asked should, on balance, count against the paper, which is just a head scratcher. I thought we're supposed to publish novel results and important questions and so on, including those that haven't yet been asked. Here's one from another underinformed reviewer. It's a bit strange that you used Python when you could have used SPSS or MATLAB, two objectively inferior software packages for statistical analysis. But for some reason, this reviewer thinks that they were preferred, including to the point that some explanation is needed. Is this really just a discovery, or just the confirmation of math? We could go on forever, but this is the last one I pulled. This is just off the very first page on the blog as of yesterday. This paper does not offer a revolutionary breakthrough. So this reviewer is really setting the bar high for publication. It's sort of revolutionary or none at all. Completely unrealistic and really not what it's about. So I've found that, in my experience, there tend to be two, there surely are other types of reviewers, but a lot of them I would say fall into kind of two main categories or types. One is the type of reviewer who thinks they're the gatekeeper and they think their job is to criticize and sort of keep papers from being published. That's a bad kind of reviewer. I hope you don't take that perspective on your reviewing. Another kind of reviewer is the one I think is helpful actually, and is hopefully helping the enterprise. And that other kind is reviewer who thinks it's their job to help make the writing better, right? And offer constructive suggestions. Of course, every once in a while there is a paper that is just really not up to snuff, but I think those reviewers should defer to the editor. That's my personal opinion on that. So here's one. I do randomized controlled trials as sort of one of the big picture things that I do, and I do it in the field of math education where there's not a lot of warm fuzzy feelings about math or randomized controlled trials. So this, I'm not going to name the specific journal, but I will tell you it's at least one of the top journals in my field. Submitted a randomized controlled trial to this, and I'd like to, this is probably my single most memorable comment from a reviewer. It starts with, what does block on mean? And by the way, blocking in randomization procedure has to do with sort of, in this case, we had teachers from quite a few districts and educational consortia in the state of Florida who applied to participate. We put approximately half of them in the intervention and the other half was serving in the comparison group. And blocking means some of them had like only 4 from a district, others had like 20 from a district and so on. So we decided to block by district, which means that we would sort of consider each district sort of its own block and then randomize within there roughly half of them to the intervention and half to the control group. So the idea here being like, it's possible if these small districts, they would all be in the control group or they would all be in the treatment group. And that's kind of a bad match, right? There's something about the teachers within each school district that are more similar to each other. And so by design, we do that. So they admitted they don't know what blocking means. They could spend 5 minutes and read about it on Wikipedia, but they guessed what it means and they guessed exactly wrong. But that didn't stop them. And so then they said about our description of random assignment, they said the section is telegraphic and uninterpretable. Even that is false because it was actually much longer and more verbose than most of them are, but it was complicated and we wanted to make sure all the details were shared. So as far as I know, that word telegraphic means the opposite of that. But then they even go on and accuse us of lying and saying that we didn't actually do random assignment, right? So they accuse us of lying and question our ethics and so on. And that's just one of 4 pages of double space or single spaced 4 pages of comments like this that came from these reviewers. So there's a strong bias against randomized controlled trials, and it makes it hard for them to get published in journals in my field. So I told my wife I was gonna rant about this a little bit, and she said, you know, this is not Festivus, it's not time for Festivus and the airing of grievances. So I'm gonna stop here about this. And instead, what I'm gonna talk about is some innovations that are fairly recently invented, I think, and are really picking up steam, and there's a lot of structural support for them now. These 3 things provide a framework for talking about them, and I'm going to organize the rest of my talk around them. The ideas are pre-registration, open materials, and open data. You might be seeing in journal articles, you might be seeing these badges or something like them sometimes now published in the journal. Some journals are doing this sort of badge system. I'm going to talk about them each one at a time. So what's pre-registration? The idea is that you call your shot when you're doing a study, and even more importantly, you don't have to call all your shots, but you do need to distinguish between things that are confirmatory analyses and things that are exploratory. So you don't have to be omniscient. You don't have to know what everything's going to happen and be right about it. But this helps to sort of increase the rigor of science and the believability And there's a few different times you can do this. You can do it before you collect any of your data at all, before the data even exists. You can do it before you're analyzing existing data, say doing secondary analysis of, say, ECLSK data set or NAEP data or something, or Florida data, something like that. You also can pre-register if you're somewhere along the line in that review process and the reviewer or editor asks you to do additional analyses or collect additional data. That's another time when you can pre-register, sort of call your shot. Okay, the reviewers are insisting that I do this and they hold the keys to the gate. So I'm willing to do it, but I want to maintain the integrity and the rigor of my study. So I'm going to pre-register it. So those are all times when you can pre-register and still be kind of within the rules of the game. And I also, just for clarification, as you may have noticed, I'm mostly thinking in terms of quantitative research. This also applies to qualitative research. There's some really interesting work being done right now. So qualitative researchers, you're not entirely off the hook for the things that I'm talking about. And I hope you do get on board with it too. So a fairly recent publication in Science says more and more scientists are pre-registering. I think in education, we're fairly slow to get on board with this, but folks are getting on board. And you know, this author says declaring in advance what you're going to study and how helps avoid p-hacking and publication bias. So helps sort of maintain the integrity of the research that you're doing. If you want to know some qualitative researchers who are working on how to think about that, I'll be happy to put you in touch with them. Some places where you can pre-register. The one where I am getting more and more enamored with and appreciate is Open Science Framework, and that's the URL for it, osf.io. Another one is the SRI. There's a partnership between SRI and ICPSR called the REIS. And there's a number of other registries too, but I'm sure you can find them. You can play along and Google search them. So some of them are very domain general, like Open Science Framework is sort of everything under the sun, as far as I can tell. But others are more domain specific. So REIS, for example, is more focused on educational effectiveness. So there may be domain specific ones for your field, or there may be domain general ones. I'm becoming more and more a fan of Open Science Framework. There's a different idea related to calling your shot that I like even better personally. It's a little bit more specialized, so it only applies to something that is intended to ultimately be published in a refereed journal. But it's called a registered report, and it's not exactly the same as pre-registration. So in a registered report, the idea is if this flow here is kind of the publication pipeline of a journal article, it may start with coming up with an idea and the initial conceptualization, and then you plan a study through the, you know, motivate the study, write that up, you know, describe your procedures, your methods of data analysis and your target population, all those kinds of things. And kind of like the first 3 chapters of your dissertation, similar idea. So write up your research plan, why you're doing it, and what do you plan to do? And you can then submit that to the journal. So it's kind of the first half of your paper. And that can go through peer review. And there are a lot of benefits of this. I'll talk about them about some that I think are there on the next slide. But at that point, you actually will get feedback, may get feedback from the reviewers and from the editor. You can revise and resubmit your plan. And then it's possible for it to get accepted for publication there at stage 1. So the big innovation here that helps guard against publication bias and p-hacking and all these things that threaten the integrity of the enterprise is essentially the idea is if you're accepted, if you have a stage 1 acceptance, then regardless of what you find, that journal has committed to publishing your study, your results, as long as you're obligated as the researcher to actually carry out the study as intended. And yes, in the real world, things go wrong sometimes. And so when you're writing about that part of it in the report that you give, you just would need to be clear that, this part of what I had to do was not, this is exploratory, it's not confirmatory, it was not part of what was accepted in stage 1, but it's important to disclose. And so there is still another peer review for that latter half of the paper. But you essentially can have an accepted publication after stage 1. So some of the benefits are, for those of us who are old fogies, it might be weird and uncomfortable, but I think, for newly minted PhDs, it's pretty much the same as a dissertation perspective in a lot of cases, prospectus, sorry. And this whole process can guard against that publication bias. Another huge benefit is right at stage 1, before it's too late, when you're still planning your study, you get feedback from a group of experts. You get a free advisory board, essentially, to help you make your study better. That's a really big benefit of a registered report. I think it expedites the publication process. In my opinion, you can, after stage 1 acceptance, should be able to put that on your CV as a publication. Of course, that's my opinion. It may not be universally agreed upon. So, but you also can then still pre-register, if you choose to do that, your accepted stage 1 protocol, right? So that I don't see many downsides to a registered report. I think they're really great. For full disclosure, I haven't done one yet myself. I'm in the middle of writing one right now with some colleagues, but I am committing to doing this for at least all the major research questions on future grant-funded studies that I do. So just a list of journals that have this option of registered reports or have had this option are journals like AERA Open, Assessment, Journal of Ed Psych, and so on. There's a list on the Center for Open Science website of some journals that may have that, so you could get a sort of a little hint as to which journals may be open to such thing. My suspicion is that this list is going to be growing quite rapidly, especially with the new memo that came out from the White House as far as open access publishing. I think this is sort of in the same theme. So I want to take just a quick moment to ask you all, not just a rhetorical question, but what question, comment, or concern do you have about pre-registration or registered reports? You can feel free to use the chat or just verbally ask a question or make a comment. Or I can move on. The next topic is much scarier. So I guess we should just dive right in.
Hey, Rob, Phil
yeah.
did ask, he says, in your experience, have you found it very time consuming to pre-register a study?
Extremely time consuming to pre-register a study. Even after I have like a really, a funded grant proposal and it's in theory, it's all written in there. It's extremely time consuming. I am not a fan, to be perfectly honest. It is becoming a requirement by some federal funding agencies and I think also some private foundations. But it's difficult. It's just one more of those things that does take time. Maybe as we sort of get more in the habit of always doing it, maybe it'll get easier. But if you really are trying to do a good job and a thorough job with your pre-registration, you're trying to think about all the different things that can go wrong in your data analysis. and all the things that you're going to do in response to that, missing data problems, erroneous data problems, models that don't fit, all these kinds of things. It's really hard. So I'm not going to lie about that. I have done some pre-registrations. I've also neglected to do some pre-registrations that in retrospect, I wish I did. But it's easy to, if you and your colleagues agree like, we don't need to do it, it's much easier to just not have that thing on your to-do list. Okay, but I want to talk about the next thing, something that's even harder, is open data is the next badge in this framework. Sorry, I didn't mean to click that. So this is a rhetorical question. Sort of how do you feel about sharing your data from your study? If you don't have any feelings at all, then I think you haven't really thought it through. Yeah, sharing data is scary. Yeah, I agree with Colleen that pre-registration, a lot of that planning up front can save you some time later. It also runs the risk of going the other way too. So I would say just sort of some important things from the perspective of science, right? Sharing your data increases both the quality and the rigor of your research, right? I think it improves the quality because for one thing, it enables others to try to reproduce your findings, right, at the simplest level, to help make sure that, you're not the only one who found that. Maybe you clicked the wrong button if you're using a point and click software system, or maybe you missed a line of code if you're using some other software system. Maybe you made a copy and paste error, which is the most common error that I find when we're looking at preliminary results. All these things potentially can be caught. And if you're exposing your data set and your replication code and so on to that, that's scary. But it also is, I believe, the right thing to do, because it helps us not sort of be misled by spurious findings or incorrect findings that are reported. Another good reason, an important reason, is there are always important questions that can be asked of your data that you're just never going to have time to ask of the data. Or maybe there's going to be software or theoretical frameworks available in the future, 10, 20, 30 years from now, that you don't have right now. And your study could be revisited then when some of those innovations have come into the light. So the legacy of your data, the potential for the legacy of your data is much greater if you share it, and if other researchers can use it. I've come to believe that that's really the largest legacy of the work potential legacy of the work that I'm doing. It's important that we write some papers and share some results, but that data can be used creatively to do all kinds of good in the future. And one of the most important reasons is also the reality is there are only a select few of us who actually end up getting funding to do research. That can, there's never going to be an infinite, unlimited amount of funding. But sharing your data can provide opportunities for junior researchers, for researchers who maybe don't live in the US system where there's funding available for research, and so they're not eligible for it. And for those who just sort of, maybe grant writing is not their talent, but analyzing data and thinking about that carefully is their talent. So it really opens the gate to science and to the academy. And that's a really important reason to share your data, in my opinion. And we can just squeeze more juice out of it. So why bother? The worst reason is that the federal government is insisting on it, right? But that's also a valid and important reason. Some private foundations are also requiring data to be shared. a better, a bigger reason, I think, is to amplify the legacy of your work, and another equally important reason is sort of opening the gate, and allowing others to use that data and help us all to gain insight into the things that can tell us. So here's a real question, not a rhetorical question again. What concerns do you have about data sharing? And you should have many concerns, but I'd love to hear thoughts that you have at this point.
How do you feel about data sharing using like Shiny apps and stuff? Well, specifically the Shiny app, like, do you think that's a good route to go in terms of like sharing your data, or do you think it's better to just go ahead and present out the whole thing so other people can use it as they please?
Well, I mean, my opinion is, what's your purpose of sharing it? Are you selecting from, something that tells a story that you're trying to tell, and maybe there's all kinds of bias built into that. That would be one concern. I think it's important to share all your data to the extent that you can. And sometimes data, when I think sharing data, ideally, okay, what I'm striving to attain is you're even sharing all your decisions, like your meeting notes, your basically your whole lab notebook, and all those sort of decisions that represent those many thousands of researchers' degrees of freedom. Ideally, that's also shared with your data. Background on how you collected the data is really important for interpreting what the data mean. And Crystal Lewis, I just saw, by the way, I'm sort of embarrassed to be talking about this right now, knowing she's present. She is a data management expert. And Crystal, please feel free to correct any misstatements that I make.
You're doing an amazing job, Rob.
All right, thanks. But yeah, so I don't know if that answers your question about that, but I would say the goal to strive for is share everything you can about your data, including decisions you made about how you collected it and how what kind of clean work you did to clean it and so on. I can't say that I've attained that in any case, but we're striving for it. But yeah, there's another really important question, right? Well, here I'll jump to some list of concerns that I have, that I've predicted we would have. I think the first and foremost, sort of making sure that we're maintaining privacy, confidentiality, respect for persons, research ethics, and HIPAA and FERPA and IRB and all the alphabet soup of ethics and laws that we are expected to maintain. So that's one of the most important concerns. And de-identifying your data before you share it is not a simple process. It's important to make sure that you're doing that very carefully and very deliberately. Making errors, right? So what if somebody finds a mistake in my results? That's a scary thing. In fact, some of the people right now who have become the world's foremost data management experts got that way because they had very high profile mistakes in their findings, and they really learned the hard way how important data management and workflow and all that is. Getting scooped is another common concern about that. All that additional work of cleaning it up and documenting it and explaining what all your variables mean is a tremendous amount of more work. And if you consider it intellectual property, sort of how do you want to share it? Do you want to just share it freely? Do you want somebody to contact you if they want access to it? What kind of credit are you expecting, and so on? That all falls in there. So there's a lot to think about, a lot to learn about, a lot to talk about when it comes to sharing data. these are, I'm going to blow right past these, but this is something important to learn about and think about: the FAIR principles. Just two really detailed things in there that or really general things in there. One is it's really important to explain what your data are, how you got them, what the variables mean, the context and all those kinds of things. Another is please, 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 as somebody who suffers almost daily from dealing with SPSS licenses that are difficult to manage at best, to the extent that you can share things using software or file types that are not proprietary, that's really important too. So saving things as a CVS or .dat or something like that. Deidre, I'll speak to intellectual property, I think, in just a moment, but very quickly, there are many data repositories. There are many more data repositories than there are places to pre-register your studies. Open Science Framework is a big one. The sort of grandparent of them all, I think, is ICPSR. FSU is an institutional partner with both of those organizations. FSU has really been forward thinking, as far as I know, about sort of open science and open access and all these kinds of things. Another sort of large repository is Dataverse, but others, LDBase is one I want to mention. That's Sarah Hart and her colleagues here at FSU have that. It's more of a domain specific one for developmental psychology. A really neat feature of their system is the goal is to sort of support integrative data analysis, which is a great idea. And just like Crystal said in the chat, Sarah has also shared a lot of resources like sort of templates for data management plans that you can use, because a lot of those are required now in grant proposals. I'm also happy to share mine. I've got some glowing reviews from reviewers who didn't recommend my projects for funding, but really liked my data management plan. I'm happy to share that with you. But the fair warning on that is it sets the bar high for what you're promising to do. And you can't, as far as I know, you can't just drop it in to your grant. You're going to need to think it through and make sure it makes sense for yours. You know, GitHub's another place that's more for sharing code typically. But it's a great repository. And I'd be remiss if I didn't mention open educational resources also in this whole conversation. That's another place to share sort of teaching tools. And there's so many more repositories, but these are just a quick overview of some. So open materials is another important aspect of all of this. And in my case, I often think in terms of open measures. I think this is really important for comparing across studies. If you're saying you're measuring the same construct, but you're measuring it in a different way, then I would say you're definitely not exactly measuring the same construct, right? Or maybe you are, I don't know, but we kind of need to know that, right? If we're all calling something the same thing, but we're measuring it differently. So I think it really helps with full disclosure, which is a really important tenet of all of this. Enables scrutiny. So maybe you're calling something a certain construct, but you're measuring it in a way, and maybe that's not how others would, the way you're measuring it is giving you something that's not exactly what others would call that thing you're calling it. That's another important aspect in the whole open science idea. It also enables cooperation. So I mentioned kind of opening the gate to junior researchers. I want to give a whole bunch of credit to Susan Empson. So she's a senior scholar. When I first got my first randomized controlled trial grant funded to study CGI, it was really, as these things go, it's really exciting for 5 minutes when you learn that you're getting the grant, and then suddenly you're terrified because now you have to do all those things you said you were going to do. And one of the things that we said is we're going to try to measure a lot of the things that they measured in the original randomized controlled trial of CGI. And I knew immediately that was going to mean a tremendous amount of measure development. And I ended up in a conversation with Susan Empson, who was a graduate student at the time in those early CGI days. And I had long been searching the Wisconsin Center for Education Research website because there's a lot of research reports and things that they published and cite in publications that are kind of in that you can't ever find it, but it's been cited a lot of times. A colleague of mine calls that the phantom. You've heard of gray literature, like non-peer-reviewed literature. A colleague of mine calls that the phantom literature. Stuff that's cited, but you can't actually find it anywhere. So there's a lot of these things that I was finding and sort of hitting dead ends, and I had contacted Susan Empson, and she agreed. She had this binder, I have it right here, copy of it, of all the measures and all the protocols they ever used over those years for like 5 years of studies, like the interview questions for students, the problems they use, the coding protocols, the training manuals, and so on. She had those in hard copy. This is 2012 on her shelf. And she said, you know what? I can just scan that and send you a copy of it. And so she sent me a hard copy in the mail of all the measures they ever used 20 years prior, and really helped me because measure development is tremendously resource intensive, and people just don't have time. And actually, if we can be using the same measures to the extent that that makes sense across studies, that also is improving the quality of the science that we're doing or the research that we're doing in general. So in the meantime, we've done a lot of measure development in my lab. We've developed measures of teacher knowledge, teacher beliefs, teacher math anxiety. Of course, that's really Colleen's project, but I'm claiming some credit for it. Measures of instructional practice, measures of student thinking and performance in math, measures of student attitudes and anxiety. Oh, I'm missing an S on that one. So in the meantime, and so one of the places where we are being the most aggressive about sharing data and sharing measures when it makes sense is to do that. So this is a page in Open Science Framework where we just published this week the psychometric report for the 2020 K-team. That's the measure of teacher knowledge, teachers' mathematical knowledge for teaching that we started developing in 2014, and we've used and continued to try to improve and field test every year since. So this has a sample, has a sample of, I don't know how many, 700-ish, because then you might know.
Yes.
700 teachers. I'm not going to walk you through it, but you're welcome, actually invited to go to osf.io and search for this. You might need to find the place where you're searching data, not just searching generally. But you can see we put tags for the names of the co-authors of this. Inside here, we have an overall abstract. We have the data, the source data, and then the sort of clean data that we put in there after looking at missing data patterns and so on. We also have our syntax for our psychometric analyses, both using classical test theory and item response theory, and our initial getting to know the data set, looking for missing data and so on. The data files are there, the syntax for that is there, the output files is there, and a summary of what we found in the test blueprint. In this case, I don't actually share the actual test items because this is a performance assessment, and I need some security on those so that, you know, a program developer can't just sort of design their program around exactly what we're testing, right? But on other things like questionnaires about teacher beliefs and so on, we do share the items or intend to share the items if we haven't yet. So one thing that's happening on this is there are folks either with our measure of teacher knowledge or teacher beliefs at Georgia State, at University of Virginia, at UT Austin, at Louisiana Tech, at UC Irvine that are using these measures. And I'm really excited about it. And one of the things I think that they're excited about is they can leverage our sample and our item parameters to sort of score their data. They may have only 30 teachers, but they can leverage our sample of 1,200 teachers and score the data with some vertical scaling. And we share the syntax in here to do that and the item parameters to do that. So that their scores from their sample are directly comparable to our scores in our sample, right? So this is good for us all. Another thing, if you'll notice, the license that I think I'm putting, I think all of my data in, I say mine, but it's really owned by FSU, is under the Creative Commons by Attributions license. So that means anybody's welcome to access the data, to use it for their purposes, even use it differently than we did if they choose to. But the by attribution part means that we do still expect that they give us credit for it. So cite us in their publications, things like that. But otherwise, this particular license, I'm not expecting that they're going to write to me and ask permission to use this. I just don't have time for that. I'm happy to hear from them, but I don't want to have to put myself as a gatekeeper for using the data. So going very quickly through the end of this. So if you want to learn more, I encourage you to learn more about licensing, especially under the Creative Commons. There's a lot of different kinds of Creative Commons licenses, and you can sort of choose the one that matches your preference. One thing that I'm also excited about, we have 126 one-hour-long videos that were professionally produced, first and second grade classrooms. We've generated transcripts of those videos and have de-identified those. One of the many things we're poised to share within the next few weeks are the transcripts for all these videos. So once again, this is not all just quantitative data that I'm talking about, but I have a colleague at UConn who does natural language processing. She's using them for that, but then we're going to put all those transcripts out there for others to use in whatever way they see fit. I'd be remiss if I didn't mention open access publication. I'm going to go real fast through this, and I'm going to skip that question. So there's lots of types. You can publish preprints, or we could call them working papers. I think those are fairly synonymous. Just research reports to create some gray literature and not phantom literature. You can publish in journals under gold open access or green open access. That has different meaning. I encourage you to learn about that. There are places, some ideas for places where you can publish are digital. If you're not aware of FSU's research repository, I strongly encourage you to become aware of it. It's a great resource. They're really supportive. It's through the FSU library system. You can get a DOI number, for example, for something you publish in there. So it's really official, verifiable. Folks can find it now and in the future. And they're also quite fast. So they're usually within a week or two, they have it published and up and running. But if you need it even faster, you could contact them and let them know. Other places are like edArchive or SciArchive, things like that. You can also publish in Open Science Framework. And a lot of journals support open access. You can find them by going to this website, doaj.org. Directory of Open Access Journals, and search them. If any of y'all want to do us all a favor and find the ones that are at that intersection between they have open access and registered reports and their SSCI or SCI indexed and so on, that's something that the ones that are at that intersection point are the ones that are going to thrive, as far as I'm concerned. So in digital, here's some things that we've published. The center one is a work we published as a working paper. It's under review right now. I did check to make sure the journal was okay with that, and they were okay with that. Their response to me is they expect their reviewers to not go try to find out who wrote the manuscript and to sort of respect that masking. But we've also published, some of these randomized controlled trials are really difficult for me to publish in math ed journals, in my experience. And so this is a quick way to get them out there so they can help inform things that folks are doing, and while we're trying to get them published in a refereed place. So I think that's all I have. Oh, there's this White House statement. Get familiar with it. I'm not going to rehash it to you. Some resources here at FSU. We have the Open Scholars Project. It's a community of folks who are interested in this, and they're in the arts and natural sciences, social sciences, all across the university. You can get involved with that. There's an open access publishing fund. So get familiar with that you can get funding from the library if you need to pay an open access fee for a journal, as long as that journal is dedicated to open access publishing. So that's a good thing to know. You can be the main author on one a year, the last I knew. And we have institutional partnerships, and there's a brand new open science librarian here at FSU, and she's a great resource also, so take note of that. And the Open Science Circular, you can sign up for that. Renane, I'm sure you know Renane. If you don't, you should. He, I think, is the editor of that, and you can get a quarterly newsletter about important things related to open science in your inbox. Okay, I'm going to quit now, or at least stop and take a breath. Sorry about the fire hose of information.
So we have about 3 minutes left in our time. If anyone has questions for Dr. Schoen.
Hi, I'm Carolyn Harrington, and I'm in the Department of Education Leadership and Policy Studies here at FSU. I don't have questions for him. I just want to thank him for presenting this information. It is critically necessary, particularly for junior scholars as they begin their careers, because the landscape is changing and it's changing rapidly. I was editor of Educational Researcher, which is one of the senior, most highly regarded journals in education. And I can't tell you how many times reviewers would look at an article and say, this is great, very well done, but we already know this. And there wasn't a consideration of the fact that findings need to be repeated. The data, the means by which data are collected, by the criteria needs to be interrogated mercilessly and repeatedly. There just simply isn't a recognition of that. And to me, it was concerning because one of the most prestigious journals was getting, which Educational Researcher was getting reviews back from people who just the sheer fact that previous research had found similar findings. But we know that that's not the case. We know knowledge is like a brick wall, and you add a little bit here, you add a little bit there, and you never really stop adding. You never really know the thresholds. Do you know enough to make policy decisions, or do you know enough to make practice decisions based on this data? But one study is never sufficient. And I think in academia, we have, with the best of intentions, contributed a little bit to regarding publications and the status of the journal as a overly singular measure. I mean, in fact, it's just one of many measures. So I want to thank Rob for doing this. I also wanted to just say a little bit about there's I think a lot of credence given to fact checking, which reigns high in a lot of arenas, but there's not enough attention given to theory checking. And I think when you have to register your methodology, that requires more scrutiny about the assumptions that underline your hypothesis. And that needs to be done too. Of course, they're both variant, but sometimes I see a little bias toward the evaluation of the empirical methodology and not enough attention to the evaluation of the theories themselves. Anyway, thank you.
Thanks. Yeah, even Shadish, Cook, and Campbell, sort of, they wrote the book on experimental designs, right? They'd say in chapter 1, even a randomized trial ultimately requires at the end the qualitative interpretation of what's going on. So, and the sort of interpretation of theory and so forth.
It's right at 2 o'clock. So we appreciate everyone coming this afternoon. And of course, we'll be in touch about October's colloquium. Mel, I don't remember right off the top of my head who we have for October. Do you?
Yes, it's Dr. Taryn Wade.
Oh, that's right, Dr. Wade. Okay, so she will be here in October. So you'll be seeing information circulating about that. And thank you, Rob. Thank
Thanks.
you, everyone. Have a great Friday and rest of your weekend.